today we're going to be learning, firstly, is to calculate your pH, POH, and we're also going to be writing ionic equations, which is something that we've done a little bit of. Remember when we talked about conjugate acids and bases?
Yeah.
Yeah, so we're gonna build on that. So every week we're kind of putting on another layer of the information that we learned from last week. So I think that's the plan for today, because we already have 60 minutes, but we're gonna try to cover as much as possible. So that's at least the plan.
Without rushing, because we've got time.
Yeah. So I'm thinking that if we do 2 dot points today, we've got heaps of time. You've got like 8 weeks till semester ends. We've got heaps of time.
Yeah.
Okay, so we're going to use whiteboard because I think that was a bit easier for you last week. Was that correct?
Yeah, that made it a bit simpler.
Okay. So, can you see my whiteboard and my lovely lilac color?
Yeah.
Let's see if I can change it to something new. Let's do dark blue today. So let's do dark blue. So, this is the first dot point that we're going to cover, and that's calculating pH and POH from an acid or a base. So the idea of this dot point is there's 4 main components. The first point is, as you can see, is to calculate the pH, the POH, but then each of those points you'll be given an acid or a base. So in this situation, as you can see, we're looking at stomach acid, so hydrochloric acid. Can you see?
Yeah.
Perfect. So our first really easy question, by the way, it's going to get harder, is to calculate the pH of HCl with the hydronium ion concentration of 1.2 times 10 to the negative 3 moles. So how do you think we're going to be doing that today? So how are we going to work out the pH of this?
I can't remember what the equation for pH was.
Mm. Can you still see my whiteboard? Yeah.
Oh, my dad just guessed it. It was just minus log to the hydrogen concentration.
Your dad actually still remembers chemistry. I'm proud. Congrats to him. Good job. He's correct.
Yeah, Dad, good job.
Yeah. So we're going to be calculating the pH, and the pH equation is the pH is equal to the negative log of the hydrogen ion, or in this situation, it's going to be the hydronium ion, as you can see.
Yeah.
Cool. So what's our step 2? With step 1, we've written our equation. What's step 2? What are we going to do next?
Change our subbing the hydronium ions concentration, I suppose.
So what are we subbing in? So we're going to do pH equal to the negative log of
1.2 times 10 to the negative 3. Well, yep.
Do you have your calculator? What's that going to equal?
I'm just writing it myself.
Perfect.
Negative 3 and pH equals. Okay. Where's my calculator?
Let's see if we get the same answer.
I always wondered what log was used for on a scientific calculator. Like, I just saw that and I'm like, okay, what's that done? What does that do? Okay, so negative 3 to get 2.9.
2.92? That's what I got.
Yeah, 2.92, yeah.
Perfect. So
that's the pH.
Perfect.
Okay, so we have below 5, so it's acidic.
We can guess that logically without having to calculate the pH.
We can. We've got hydrochloric acid. Yeah. What is it?
Remember,
what's in its name?
I highlighted that point at the start when I was like, this is stomach acid. It's acid, it's acidic, and if it's acidic, the pH will be less than 7.
Yes.
Perfect. Good. Now we're going to do something different.
Yep.
Let me just post, because I've got a Word document of all the questions, but I can't show it to you like this. So I'm just pasting the questions in. All right, question 2.
The luxuries of having 2 monitors.
Yeah, I don't have 2 monitors. I have a laptop that's barely working. Anyway, so we have question 2, which is calculate the hydronium ion concentration of blood. The pH is 7.3, so we can see it's slightly alkaline, which is really nice for the question. It tells you that it's basic, right? Because alkaline substances are basic. So this question is actually the opposite. We've got the pH, but we're trying to now work out the concentration. See how questions can be, I remember how I always tell you questions, you can go forward or you can go backwards when you're trying to work out your solution. So this is a situation where we're going the polar opposite, we're going backwards. So what do you think the step 1 of the question is going to be?
So we're going to have to somehow rearrange the equation.
All right, let's just firstly write the equation. What's going to be the equation?
Yeah. So pH
I like my equation.
minus log bracket H3O plus bracket close bracket. That is.
And that's equal to 7.3. Do you agree?
Yes, in pH, yes.
Yes, because we know the pH. That's an easy part. That's fine. So what's going to be step 2?
I think maybe 7.3 equals minus log bracket H3O close bracket.
Close, but you've brushed a bit forward. So what you should do, I hope you can see what I'm doing, is you're going to do H log of H3O. Oh my god, I need to learn how to. Right, perfect. But that's going to equal to negative 7.3. Can you see what I did there? So I got rid of the reverse. Yeah, so I've times both sides. I times this side by -1, and I've times this side by -1 as well. So as you can see, you're going to now just have log H3O plus equals to negative 7.3. Yeah?
Okay, I might just write this stuff down quickly.
Okay, sure. Worst comes to worst, I can always send you the recording from like last week.
Yeah.
Did you listen to the recording last week? Yeah? All good?
I didn't need it. It was all right. I got it. I had other questions in my book that explained it to me. Plus, it was kind of long, so.
Yeah, it's like an hour and a bit. All right.
All right. Calculating hydronium. Okay. I'm just writing above the question what exactly we're doing, so I don't have to write the actual question. Calculating hydronium concentration.
And I'm just writing down the next step.
Point times what does log actually do?
What do you mean? Log is a number.
Yeah, well, so log's a constant that's represented by log, is it?
Well, in a way, yes. Because look, if you're going to do, let's say, log of 1, you're going to get 0. But if you're going to do log of 2, it's 0.3.
So you put you put H3 equals 10 to the power of -7.
Yeah, 7.3. Correct.
Why'd you do that?
Because you're taking the negative log. You want to get rid of log, right? We want to make H3O the subject of the formula. Do you know how we're trying to find x and we want to make x on its own? This is a similar situation where we want to get H3O or the concentration of H3O on its own. We don't want any logs. We don't want any numbers. We just want it on its own. So to get rid of log, because look, okay, follow me. Get your calculator out and put 10 to the power of, let's say, log of 2. Have a look. What do you guys an answer?
10 to the power of negative.
No, put 10 to the power of log 2.
Oh, log 2.
Yeah, it's just an example. I want to show you why we're putting
close
log.
bracket.
Yep. So you're going to get 2, right?
2. Yeah.
Yeah. So in this
How does that
situation,
work?
it's the exact same. If I'm going to put 10 to the power log H3O, my answer is going to be H3O. Does that make sense?
Yeah, what does exactly the log do when it's to the power of something? Like
Why?
it's timesing that thing by log.
Don't worry about that, Heath. You don't need to know that. Just know that what you're trying to do here, you're taking the power of 10 of each side, is because you're trying to get this. You're trying to get H3O on its side. And the only way you can get rid of log is to put it to the power of 10.
Okay.
So, and
Right.
as you know, what in maths, what you do to the left side, you have to do to the right side.
Yep, makes sense.
So what if you're doing 10, you're going to do 10 to the power of log H3O, you're going to have to do 10 to the power of negative 7.3. So this 10 to the power of log, see, you get rid of it. In the next line, you just get H3O, so the concentration on its own, and you're going to get 10 to the power of negative 7.3, which is going to give you the concentration.
Yep. All right, makes sense.
And that's what I got as an answer.
H3O. Negative 8. Let me see.
Yep. That's what I got.
To the power of negative 7.3. Let me change that.
Yep, so 10 to the power of negative 7.3.
So it's 5.01 times 10 to the negative 8. That's what I got.
Perfect.
Okay.
Perfect, that's what I got.
Okay.
All right.
So I got to remember that to get rid of the log, you have to type to the power of 10.
Yeah, that's going to be every single.
That's the part that I need to remember.
Yep. And hopefully it's in your mind.
Is this another concentration? Calculation of pH. What's the difference between pOH and pH?
Okay, so pH is to do with the hydrogen ion concentration, and pOH is to do with the OH concentration. Does that make sense?
Okay, so this is for bases instead of acids.
Yeah. So remember how I said this type of question, there's 4 types of ways that they can do it. They could do pH, like acid, pH, base, or they could do, let's say, calculate the concentration acid or calculate the concentration base. So we've done the first type, this is the second type, and now we're doing the third type, where they don't care about the hydrogen ion concentration, they want to know about the hydroxide ion concentration.
Yeah.
OH.
Yeah.
So, see, at the top we did the calculation of pH from a H3O ion, a hydronium ion. Now we're doing the calculation of the pH using hydroxide. So
yep.
Our question's quite simple. It's what are the pOH? Oh, see, this question asks you for both, but it's good because it's going to make you practice both pH and pOH. So what is
Why do they call it pOH in chemistry? Because pH is both how basic and how acidic something is. Is it just because pOH because oxygen because of oxygen OH?
pOH is more just to do with the basic situation. I know what you mean. With your pH scale, it talks about all the hydrogen ion concentrations, right?
Yeah.
So you can have a pH of 14 and you can have a pH of 1. But in this situation, pOH is good because it shows you, it has more to do with how many hydroxide ions are present, not hydrogen ions.
And then that's only really useful for chemistry itself.
Correct.
And chemistry uses, yeah.
So as you can see, this time we don't have hydrochloric acid like we did at the first question. We've got potassium hydroxide, right? And again,
Yeah, for once we don't have to write equations.
Who said we don't have to write equations?
No, we don't have to, before doing the calculations, we don't have to have an equation for this.
So, and we got given, oops, where is my little whiteboard? Yep. So what we're going to do here, we're going to calculate both. So this is practicing pH and POH. And just as opposed to those situations, POH is always, it's always going to be, do you know POH is 14 minus pH? Does that make sense? It's the reciprocal. Okay, let me show you so I don't confuse you. All right. Act as if nothing, as if I didn't say that to you. And let's focus on the question. So what would you do the first thing in this question?
Is calculating pH use the same equation or a similar equation to pH?
Yep. So what you're going to do is you're going to do POH is equal to negative log of OH.
Yeah.
Does that make sense?
Yeah, and our OH concentration is
equals to negative log 0.0125. Do you agree with that?
Yep.
Same, as you said, same procedure as if you're calculating, let's say, pH. Let's say we're calculating the pH of hydrochloric acid. Same situation. You're going to write negative log of not pH but OH, and then you're going to insert your concentration, right?
Yep.
Perfect. So what is that going to give me? Your
let me
calculator.
see. Yep. So negative. Is there a positive log at any point? Is that useful?
Nope.
Okay. It's possible, so it must be useful for something.
Right, but we're not
relevant.
Yes.
1.9.
1.9? Yep.
Yeah.
Let's do it to one decimal place. I agree. That's what I got. 1.90. So does that make a bit of sense?
Yeah.
Perfect. Now, this is where it gets a bit tricky. All right, is that okay if I delete question 1?
Yes, you can delete
because I'm
question 1.
running out of a bit of, oh, that's better. Now, what I was talking
Remember,
to
you can make new pages instead of having to.
Yeah, but I like
delete
having
them.
my little page. Leave my little page alone. All right. So remember how I was trying to tell you that pH plus POH always equals to 14.
Yep.
Right. Does that make sense?
So when you add a pH to an OH, it equals 14.
Always correct.
And
So
because 14 is the what's it called, is neutral, isn't it? No,
no, 7 is
7's neutral. It's half
14 is as alkaline as you're gonna get ever. That's corrosion at its best.
Yeah, but okay, that doesn't make sense for me. Why is it 14? What's the reasoning behind it being 14? Is it just
honey,
because it
I'm
is?
a chemistry tutor, but I don't know why it goes to that. I think that's pretty much the maximum amount. It's okay. So look, pH. Look, let's say pH 1 is your smallest amount of hydrogen ions that you could have present, and then pH 14 is the least amount of hydrogen ions that can be present within a substance.
Oh, okay.
All right. Right. Are you following what I'm typing right here?
Okay. So you get your pH by minusing POH from 14. Yeah. And then you do the reverse to get POH.
Correct. So sometimes your chem teachers can be mean, and they can be like, calculate the POH, but I don't want the POH, I want the pH. And some people get really freaked out, like, oh my God, I've got a POH. How the heck am I going to calculate the pH? It's easy. You just do 14 minus, and you get the answer. It's nice and pretty and simple, because it's always the same. There's like no surprises whatsoever. So as you can see, what we're going to do here is we're going to do pH minus.
Also, we need to find out our pH so that we can take that from 14 to get a POH. Or can we do it without that?
Pardon me?
Do we need to find the pH so that we can take that from the 14 to get the POH?
No, we're finding the pH. We've got the pOH.
Okay.
Can you see?
Wait, do we? Oh, yes, we do. That's right,
We
because
do.
we have
What
that.
did yep. Does that make sense? We worked it up
Yeah, yeah.
upstairs. Remember the first
Good.
thing we did was negative log of OH. So we've worked out the pOH. We got 1.9. We're like, okay, that makes sense. Then we're like, okay, if I have to work out the pH of a solution, what I can do is I can do pH, to work out pH, I'll do the 14 minus the pOH that I got above.
Okay, so then, which is,
Calculator time.
yeah, okay. I'm just writing down what you wrote first. Times